Okay, now I'm back. It's George. I'm back for the second part, and I'm here to explain how whole meteors can get through the mesosphere. Okay, you have the exosphere, you have the thermosphere, and then you have the mesosphere where the meteors burn. Then you have the stratosphere and the troposphere. Now, in 1833, you had the Great Meteor Shower. Okay, sky watchers first noticed noctilucent clouds in 1885, 2 years after the eruption of Krakatoa. Okay, you also have polar stratospheric clouds in the stratosphere. Now, all hot air from meteors rise, making air denser, which means it makes the air thicker and it's harder for, it will slow the rock down is what it will do. Okay, smoke will only rise as long as it is warmer than the surrounding air. Now, when you keep all that in mind and you've got a million meteorites in an 8-hour period releasing all that smoke and pummeling the atmosphere, if you don't think that it's going to change the density of the air, well, then you're wrong. It does change the density of the air, and it probably did it in more than one layer of the atmosphere. And basically the rocks during that meteor shower would have been dropping like this. And that's about all the faster they would have been going. They wouldn't have been going the normal speed. Now, the 1833 meteor display, I looked it up in the New England Weather on the Colonial Senfei or whatever. Okay, now it said, one of the grandest and most remarkable exhibitions of natural phenomenon ever witnessed in this part of the world was observed on the early morning of November 13th, 1833. In all parts of the heavens, which were clear and serene, meteors fell like snowflakes or shot like sparks flying from a piece of firework. Okay, fireworks don't go no thousands of miles an hour. This is what people are. You've got to interpret and understand what the people saw this, what they saw and what they're describing. Snowflakes, fireworks, okay. There were various sizes, some being as small as fixed stars and others very much larger. They began to fall and shoot at midnight and continued until the stars faded away in the early morning, being most numerous at 4 o'clock. The shooting meteors left luminous trails or traces of white lights. Noctilucent clouds can be blue, but they also have white lights. Now, I'm going to make a guess here that because the sky was lit up and it was so bright, people were actually seeing the noctilucent clouds being made. That's why they said they saw a white light. White light behind them, from half a yard to 3 yards in length, apparently which slightly curved downward and remained visible for 3 to 5 seconds. The meteors fell at times in such large numbers, they seemed like a shower of fire, by which name similar exhibits is known in other portions of the world. Now and then, one much brighter and larger than the rest would shoot across the sky like vivid lightning. They fell about 1/2 as thick as snowflakes. Okay, I've seen snowflakes fall. Okay, they don't whiz past my face. With intervals when but few could be seen, they produced a sound like wish, 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 wish. That's not supersonic. Gently spoken many times in different degrees of loudness. Great numbers were seen to explode like a rocket, sending forth trains of dazzling sparks, which means the meteors that were coming down, some of them were breaking up and some of them weren't. And what they saw, the trails and the sparks is the pieces breaking apart on the meteor as it was coming down. Sending forth trains of dazzling sparks accompanied by explosive noises. Now, you don't hear anything that sounds like an atomic bomb or a loud boom. They said explosive noises. Okay, so the noises were a little bit lower than normal, but you could hear it. The meteors seem to have distinct nucleuses, about half the size of Jupiter, some being larger and some smaller. And that would explain why I have the small hole rocks and the bigger hole rocks. The temperature had changed during the night and the morning and was somewhat colder. Okay, now this would have to do with the production of thousands and thousands and thousands of noctilucent clouds. It would have altered the temperature. Okay, now if you alter the temperature in the mesosphere, the stratosphere, and the thermosphere, and it makes the air denser, okay, the rocks that are dropping, they're going to go slower. And they won't burn. And they won't burn because the cold air is so cold, it's trying to put the fire out. And if people don't understand this, I don't know what to tell them. Now, we'll go to the pictures, okay? This one right here. These two pieces, they're in rock form, but they are solid metal. This looks like an interesting picture here. Okay, it's burnt. It's still intact. But when you look at the bottom side of it, wow. It looks nothing like the other side. It's missing part of it. Part of it's broke off. This one right here. This is a half of a rock. Okay, it looks good from this side. Okay? But when you look at the other side, this is what it looks like. This thing is solid metal, but it's in rock form. Now, the point that I'm trying to get, why would they still be in rock form and be solid metal? Is because it didn't get hot enough to transform the whole thing. The temperature wasn't hot enough to burn the outside of the rock like it did the inside, because the inside of the rock would be weaker. Now this is a solid metal. You could call it a rock. Me personally, I don't think they're rocks. It's solid metal. It's black. It gets blacker when you put water on it because this was in the water. And it's got all these different lines on it, which are flow lines. Now, whether people want to believe this or not, they don't have to. This one broke open. It looks like some kind of a shark. Because this is the lower jaw and the top part. And it's a bizarre thing. But yeah, people say, well, this stuff's supposed to be normal. This stuff's supposed to be normal. Here, it's amazing. I found out that Superman is real. I've got a rock from planet Krypton. That's Superman's S. This is metal. I found it in the creek and it broke apart and it's been cut. But it's been underground. Okay? So then that brings me to the questions, do aliens exist? And what really brings me to the questions, do aliens exist? Well, it's this rock right here. This rock right here is all rough. And this was buried in the ground. I dug it up out of the ground. But you look at this bottom part of the rock, and I enlarged it. That is glossy. I can see my reflection in it. How many rocks can I dig up out of the ground and see my reflection in? And this is the point that I'm trying to get across to people. You can see the light actually reflect off the inside of this. This has been cut. This is smooth. But it was buried. Oh my word. Now, from my last photo, meteors do exist. They are in present sight of people, but you have to know what to look for. If you don't know what to look for, you're not going to find them. And the reason why is any meteors that fell from 1833 had been above ground and exposed to the sun. There's certain things you have to look for in order to be able to understand what you're looking for. This one is still embedded down by the creek water. It's still embedded, but it's been exposed to the sun. Now, I threw water on it. That's why it looks the way it does. This is fusion crust, whether people want to believe it or not. It's weathered. It's not shiny black because it didn't fall today. It didn't fall yesterday. And everything here is magnetic. Now, why do I have so many different types of supposedly rocks coming up magnetic? It's bizarre. But I'm going by what I'm going by. And I can't send pictures to people, because if I send a picture to an expert, what they're going to do is they're going to look, oh, that looks like a regular earth rock. And that's what they do. But if you've never seen a whole rock or a fragment that's still in rock form because it didn't get hot enough to melt, you can go out there. I can take a coin, I can take a penny, light the flame, and then pull the flame away. Okay, does it melt? No, it doesn't melt because it's not under heat long enough. And it's the same thing that happens metal. I worked in an aluminum plant. Okay, if metal doesn't get hit to a certain heating point, it doesn't liquefy and then cool and then turn into metal. And this is what I'm trying to explain. There is a problem with the mesosphere, whether people want to believe it or not. You know, and there's not really much else that I can say. But you can't make this stuff up. You just can't. I go out there and I find what I find. And maybe eventually I'll just put everything on display and make fools out of everybody who doesn't want to believe. Because I've showed a lot of people some of these rocks. I've gone to rock shows and I've showed them. The people find this stuff highly unusual, which means there's something to it. But like I say, getting back to it, I believe the ancestors and the people in 1833 that saw this shower. And it wasn't normal. It wasn't like meteors. They didn't go shooting across the sky. They were coming down like fireworks, apples of snowflakes and hailstones toward the ground. You've really got to listen to what the people are describing. And then somebody did go up there, oh, well, the meteors, they came in like jets and hit the ground. Nobody said anything like that. And the noises that they were making, wish, wish. Now I heard the noise that the meteor in Russia when it exploded, boom, shook my whole TV set. Wish, wish. That's not a very loud noise, okay? But if you want to continue not to believe that these things exist and they're out there, there's nothing I can do. But I'm reporting my findings. And I keep finding more and more and more and more and more and more. And that's it.